Hi everyone, myself Aishwarya, faculty in Commerce Department, Bishop's Pishley College, Pallam. Today I am going to discuss about easy methods in developing mathematical model in LPP. So I wish to share you about how to make a simple way of forming LPP. Usually LPP is forming mathematical problems in LPP is complex to everyone. So today let us make it more simple. So before learning how to create a mathematical model, we need to know what is LPP or linear programming technique. Linear programming is a process of finding an optimal solution to a problem under certain constraints or under certain limitations. As we all know that business is inherent with risk. We cannot make a wise decision in every situations. We have to go through several risks. In such a situation, the importance of LPP arises. In a situation of uncertainty, how to make a wise decision. That is the major problem faced by every business organizations. So, linear programming technique is an answer to that, as a solution to that situation. Here, the business organizations can make an optimum solution, or otherwise there is a term, a wise decision or a worse decision, otherwise that have a bad decision. So the phrase itself says what is the relevance of LPP. In linear programming, we can formulate an optimal solution which is maximum suited for that situation. In that situation, that is a final problem under our certain constraints. So now let us go to discuss about how to make LPP or mathematical model in linear programming technique. So first I need to discuss about the stages or the steps involving in the formulation of this mathematical problem. So as we all know, every business organization is having an objective, a common objective. At the same time, they will be need to formulate several other objectives as per the requirements. So in LPP also, first of all, we need to identify and formulate the objective function. Objective function here means the situational objective. Does not mean the profit maximization or the ultimate objective of an organization. Here we mean the situational objective. That is according to the situation. So first step in LPP is to formulate the objective function. So here we will denote the objective function by Z. Z value denotes objective function. So objective function will be different to different organizations according to different other situations. Usually there will be maximization and minimization objectives for every organization. So as we all know, the ultimate objective of every business organization is to maximize profit maximization. But in certain other situations, there will be minimization functions also or objectives also. That doesn't mean minimization of profit, but minimization of cost. Cost is an important factor which determines the survival of every business. As we all know, cost determines the price of an objective or a product. That gradually leads to our demand maximization and minimization. So minimizing cost is another objective of every organization. So in most of the times in LPP, there will be two objectives, that is maximization and minimization, and usually maximization of profit and minimization of cost. And first step is objective creation or setting up of an objective, and the next step is, as I already mentioned, we are making an ultimate or an optimum solution at the time of a scarcity or there are some constraints. So those constraints should be taken into consideration while we are forming LPP or formulating mathematical model. So considering these constraints are the next step in formulating LPP. And for this, we need to mathematically illustrate or construct these constraints. Mathematically, we need to write them into numbers and figures in order to make a wise decision. So the second step in LPP is to form the constraints. Constraints means the limitations which is a problem for achieving our objective solution, objective problem. So second step is to formulate or to form constraints. And the last step, it is not an important step, but we need to just signify or to just need to let them know that our variables, that means these the variables which are involved in this decision making process, that may be either a product or a service, that is not a negative value, that is not having a negative value. That means it should be greater than or should be equal to 0. The minimum value of every product or the variable that we are using should be 0. So now let us look into an example, or let us make it more clear with the help of an example. So let's look into this question. A manufacturer produced two products A and B. Product A needs 2 hours and product B needs 3 hours working time. The total working time is 16 hours. Profit from A is 2 and B is 5. Formulate LPP. So here a manufacturer produces two products, namely A and B. A and B are the products manufacturing by these concerned. The situation is that working time allotted to A is 2 hours and the working time allotted to B is 3 hours. That is not a problem, but the problem arises where the total working time is 16 hours. Total working time available for A and B is 16 hours. That is a limitation here. If this is not a limitation, there is no need of formulating an LPP, because we can allot the time as our wish to A and B. But here there is a constraint, that is 16 hours time. That is 16 hours of total time is allotted by that concern to B and A. Product for the production of A and B, and the rest is profit from A is 2 and B is 5. So here it is clearly stated that profit from the production of A is 2 and from B is 5. So it is clear from this problem or this situation is that we need to maximize our profit. So first, you need to realize a fact that if in a question it is given the profit value or profit per a product or a service, then the Z function, that is objective function, will always be maximization. Or if here in the question they are used to give the cost of that product, then it will change to minimization. At all time, maximizing the profit and minimizing the cost. Cost cannot be maximized. Okay, here maximization is a object profit. So profit per product is given in this question. Profit per product is given. For A it is 2 and for B it is 5. Now for solving this problem in an accurate manner, or for mathematically representing these values, I am just giving A as x1 and B as x2 for illustrating it in mathematical form. So first we need to set our objective function, and in this objective function x1 is x1, the value of A is x1 and x1 is required to get a profit of rupees 2. So I am writing 2x1, that is the product x1 should create a profit of rupees 2, and plus, because we are adding an addition symbol because a manufacturer produces two products. So here we are making an LPP for these two products combinedly. So 2x1 plus, and the profit from x2 is 5. So 5x2. So we just formed our objective function. Objective function means what is a real problem. So the business is having the problem of maximizing profit of A as 2 and B as 5 in the event where total working time available is only 16 hours. So now our objective function is ready. Now the next process is to construct our constraint. As already I just mentioned, the time limit allotted for A is 2 hours and B is 3 hours, and the total time allotted is 16 hours. So I am going to write this constraint as this: 2x1 plus 3x2 less than or equal to 60. And from this we can understand that x1, that is product A, requires 2 hours working time, and x2, that is product B, requires 3 hours working time, and the total working time allotted for those 16. So I am here put less than or equal to simple because the maximum time available for the production of A and B is 16. It cannot exceed 16. That is why I am given less than or equal to. Less than means it can be below 16 or can be equal to 16, but cannot be greater than. That's our constraint. So here it is. Here it is a solution or here it is a constraint for the solution. X1 is having 2 hours and X2 is having 3 hours. Total time requirement is total time allotted, not requirement, allotted is 60. So this is our constraint according to this situation. Okay, from this problem, from this mathematical model, we can understood that our reset function, that is our objective function, is to maximize profit, and X1 is product A and X2 is product B. Both are from both these product we are getting 7 units or 7 rupees 7 profit, that is 2 from X1 and 5 from X2. This is expecting profit. We are expecting profit from A and B, 2 and 5 respectively, but the problem is total working time allotted. So for that we just formed a mathematical problem, 2x1 plus 3x2 less than or equal to 16. That means x1 can take a working time of 2 and x2 can take a working time of 3, but it should not be more than 16 hours. Okay, and I just mentioned earlier, these variables, that is our x1 and x2 are the variables in this problem. These should not be negative values. Negative values in the sense A should not be a value that is negative. Here it is 2 and 5 and 2 and 3. It is not negative. So we need to mention it in our mathematical model, and I'm just writing it as x1 greater than or equal to 0 and x2 greater than or equal to 0. This mentions, or this means x1 will always be greater than or equal to 0. That means will be equal to 0 or either greater than 0 and will not be a negative value, and similarly x2 is also may equal to 0 or greater than 0, will not be a negative value. So this is how an LPP can be constructed. So to conclude, here we just constructed a simple LPP model for maximizing a profit of rupees 2 and rupees 5 for x1 and x2 respectively, under the situation where the total working time allotted is 60. And this is a format of solving a problem of LPP, that is to write objective function subjected to constraints and just mention the non-negative values. Non-negative values. Okay, that's for today. Thank you.